I swear to God, it's real.
Hello, we are here and live. I think we're live. Can anybody tell me in the chat if you can hear us? Because you know what I'm like, and I tend to do muted live streams, so I'm not going to say anything until people can hear us. Anybody there? Come on, can you hear me? Let me know. I'm getting a bit concerned, guys. Nobody in the chat is saying they can hear us or see us. No, I'm getting smiley faces, but nothing else. Can you hear me, Rumpus?
I can.
Joe, can you hear me?
I can hear you.
I've just had someone say yes, so I'm going to assume people can hear us. Oh God, I hope so. Nobody in the chat has actually said they can hear us.
Can't you see the YouTube live feed and see if you're see if it's video there?
I can see us on YouTube.
Yeah. Oh yes. Okay. Finally, someone said they can hear us. Brilliant. So the purpose of this live stream is, and it's kind of changed a little bit since last night's announcement in the UK that exams might not even be going ahead this summer, but there is going to be some sort of internal assessment. There has to be some sort of assessment. So now is not the time to be giving up and deciding we're not going to bother. Now is the time where you are in direct competition with your peers to show the school with whatever type of assessment, whatever type of mock you're about to be given, that you are ready for it now. And whatever you are doing now, I assume, just like last year, is going to directly impact what you get in the summer. So, please take what we do today very, very seriously, and hopefully you get something from it. I want to thank the two people who've joined me, because I never live stream on my own because I'm useless and I can't. So first of all, can I introduce the man to my this side? He is about 1 million times more intelligent than I am. He is a proper PhD physicist. I will let him introduce himself. Over to you, Joe.
Hi, I'm Joe. I just got my thesis finished and defended in November. Here it is. Yes, a PhD in physics, undergrad in fine art.
Bloody hell.
And you've probably forgotten more about maths and science than I've ever known. As has the man next to you as well, who little blue camera. We couldn't get a decent icon up, but that's because I don't know how to stream. It is everybody's favourite. It's the Rumpus. Again, far more intelligent man than myself. Forgotten far more about maths than I will ever know. How are you doing, Rumpus?
Not too bad, though. I'm obviously quaking in my boots, the fact that I'm fighting off a PhD physicist. I mean, honestly, that's the big guns. You had to bring in the biggest gun you bloody could, couldn't you, Baldy? I'll start calling you Baldy now after that.
I thought I would.
That's a big gun to be fighting against. That really is. You couldn't. In fact, I can't think of anything more a bigger gun. In fact, actually, I'm prepared to take on any, but a PhD physicist is about the biggest.
Yeah. Well, I almost got AB Science in, but
oh yeah, he's a bit of a devil. Yes. Oh yes, that would have been scary as well. Yeah.
So the idea is that if you know someone that might benefit from this, the stream can be downloaded and you can chop it into the various important sections. I've done some mini video lessons, but we're gonna test the two people we've got next to us, who are extremely high level academic people. We're going to test them on GCSE science and maths and see actually if we can catch them out on something they might have forgotten. We're going to quiz them off a little bit against each other. We're going to have 5 rounds. We're going to start off with circle theorems. We're going to look at algebraic proofs. We're going to look at surds. We're going to look at momentum. And we're going to look at some quantitative chemistry. And everything in the stream is going to be grade 6 or higher for those people who need that bit of stretch and challenge, who are pushing that higher level. Did
you say there's some chemistry in here? I missed that. I didn't see that.
Yeah, there's some chemistry, and I've got a feeling Rumpus isn't going to do very well in that round.
I missed that one. Oh, damn it. I haven't even seen these questions. Oh, bloody hell.
Well, you know what a mole is, don't you?
I certainly do.
So you'll be fine. C4, thank you very, very much. Happy New Year to you too. Just want to thank C4 for that super chat. Thank you so much. Okay, so round 1 is on circle proofs. What I'm going to do is I'm going to bring a circle proof up on the screen. We'll have a little bit of a chat. And if you are sat at home and you are higher tier maths, you need to prove these circle proofs. You need to show that these circle proofs aren't just made up, that they actually come from somewhere. You need to be able to tell us what that proof is. So I've done a little video where you can watch. Please pause, cut that bit of video out, keep it, make some flashcards out of it or whatever. That's going to be important. But first of all, circle proof number 1. I'm going to bring this up on the screen for you guys. And it's this one. Hopefully you got the watch page open. Let me drag that right to the top. If you've got the watch page open, and people in the chat, you can play along at well. What circle theorem proof is this from school? What is that circle theorem proof? Should be on the screen about now. Joe, any idea? What is that circle theorem proof?
How are we supposed to see this? Sorry, how am I supposed to be seeing this bald cats?
Oh, I thought you had the watch page open. Don't worry about it. Don't worry about it.
Is it part of your the first one of your the first one of is it number 4 on your PowerPoint?
Yeah, I tell you what, I'll mention. I'll tell the chat what it is, and we'll get straight into the proof, and then we'll go to your questions. How about that?
I can open up the watch page. I just
superb.
Have you got the link where's the link?
It's just on the Baldy Cats. If you just go to Baldy Cats,
okay.
And it'll be the live page now.
Okay.
So, for those of you watching here, this circle proof tells us that the angle at the centre of a circle is going to be twice the angle at the circumference, as long as the angle at the centre and the angle at the circumference are subtended from the same arc, right? So here we've got point A and point B. Drawing a line to the centre from A and B gives us this angle. Drawing a line to the circumference from A and B gives us this angle. And as long as we're subtending them from those same points, we are going to find that the angle at the centre is twice the angle at the circumference. I'm going to play a little video now to prove that, and then we're going to quiz these guys on some of these circle theorems. So, here we go. Here's your proof video. So, circle theorem proofs, not an easy topic. Just make sure that when I'm making these that you are pausing each section and maybe creating your own revision flashcards or watching it until it's really, really embedded. You're not going to get this after the first watch. So, let's see. Let's begin. First circle theorem proof. Angles at the centre are twice the angle at the circumference. How am I going to prove this? The first thing I'm going to do is I'm going to draw a line from the centre to the circumference, which obviously is going to be the radius of this circle. Now I have 3 radii here, don't I? 1, 2, 3. These are all the same length, so essentially I've created 2 isosceles triangles. Now what I'm going to try and do is prove that this angle here plus this angle here is half as big as this angle here. So let's start by finding out what this angle here is. I'm going to call this A, I'm going to call this B, and you know what? I'm going to get rid of that. I'm going to call this C here. All right, so I'm going to call this A, B, C. How would I describe C? Well, I know that C plus A plus B must be 360 degrees. So I'm just going to park up here that C equals 360 minus A minus B. Okay? So if I can add together these 2 angles here that I've created in these 2 separate triangles, I should be able to show that it's half of this. So how am I going to do it? Well, let's label this angle X and let's label this angle Y. Let's just concentrate on this triangle here. If this is angle X, I know this is an isosceles triangle. So I know this angle must be X. So, algebraically, how can I describe X? What term can I come up with to describe what X is? Well, I know that all of these 3 add up to 180 degrees. X plus A must be 180. So I'm going to write that 2x equals 180 minus A. Okay, so 2x equals 180 minus A. So basically, if I take away this from 180, I'm left with the value of 2x. I can then rearrange that to say that x equals 180 minus A over 2. So that's how I'm right now I'm going to describe x. If I look at this triangle here for y, I have exactly the same. Okay, these 3 angles must add up to 180. So therefore 2y equals 180 minus b. Therefore y equals 180 minus b over 2. It's just exactly the same as what I've done with x here. So I've been able to figure out angle x, I've been able to figure out angle y, but I need to add these 2 together now and then compare them to what I've got for the angle at the centre. So how do I add x plus y? Well, it's going to be 180 minus a over 2 plus 180 minus b over 2, which gives me 360 minus a minus b, that's a b, not a 6, over 2. And that is my proof finished. This here is exactly half of this, 360 minus a minus b, 360 minus a minus b, but I'm dividing this one by 2. So, circle theorem proofs, not an easy topic. It's not the sound from the watch page off and we're good to go. Right, so that is your circle proof. There are videos on the other circle proofs, but right now, before we go to the questions, which you can join in as well on, Joe, how long's it been since you've done circle theorems? Does any of that ring any bells?
I don't remember ever seeing these before.
So there you go. So if you're a GCSE student at home, you are almost on the same level of circle theorems as a PhD physicist. So let's see how you, Rumpus, how have you done with the circle theorems?
Again, I hadn't seen those. I was aware of the arrow one, but the other ones about the angles and things, the tangent ones obviously I knew about, but about half of the ones that were there that I didn't know, and I was struggling to try and prove with those problems. I actually tried to prove. I was trying to derive them, and I found that I couldn't do that trivially. And then I had to go away and look at what these rules were. And then once I got that, everything was easy. But yeah, I was surprised that they are useful actually. That I haven't had to use them in my. I do quite a lot of this sort of thing, but they are useful actually. That's yeah, very useful. And I was mentioning to someone else actually this thing. And they said, "Oh yeah, that's rather useful, isn't it?" So there is yeah, and it's not obvious. To derive it is quite tricky. So yes, it had me definitely before I refused to look at anything at all. I tried to derive them, and I couldn't do it immediately. And so. Well,
what we're going to do now is we're going to show the chat some of the GCSE questions on circle theorems that you've been given that are dependent on some of the proofs. You can tell us, we'll have a look at the chat, see what the chat think. You can tell us what your answers are as well. And then we'll show some more of the videos about how we derive these proofs. And those are the bits that really, if you're watching at home, you maybe should chop out for somebody. They're the bits that they may be needing to watch and make flashcards on, etc. So if I just do this, this is the first question that Joe and the Rumpus have been given. We have our circle there with our funky little shape inside, and we've got to find the size of the angle ACB. We've got to find this one here. So A to C to B, we need this angle here. Let's just see what people in the chat are saying for angle C. Angle D is 51, angle A is 62. How did you find this one, Joe? I know you've got, because you've done these beforehand. Did you get an answer for this one?
I did.
Rumpus, did you get an answer?
yeah, I did. Yep.
Okay, let's see in the chat. I'll give people 10 seconds in the chat to see if they've got something. Oh, Dark Steve, member. Lovely to have you on board. Okay, nothing so far. So we will go to you, Joe. I trust you both to do this honestly and not copy each other's answers. So, Joe, what did you get for angle C?
I got 51 degrees, the same as angle D.
Same
You
here.
got 51 degrees. You both got 51 degrees.
Yeah.
Right. So this circle theorem.
I'd just like to point out that Cat does not provide us with any answers at all for this. We did actually have to work this out.
Yeah, and you've both got that right. This circle theorem is, again, angles subtended from the same arc. So if I look at D here, in fact, yeah, if I look at D here, I can form angle D by drawing a line from A and drawing a line from B, and that gives me this angle. If I was to take any other point on the circumference of the circle, let's say point C, and draw a line from B and a line from A, the angle here would be exactly the same because they come from exactly the same points. So the answer was 51. Well done. But how do we prove that? Well, we prove it this way. Okay, so the next one, angles subtended by the same arc should be even. So this angle here should be the same. They're both subtended from these 2 points here. I'll call them both x. So how do I prove these are the same? This is nice and easy, and it builds onto what we've been doing with the angle at the center. This is the angle at the center. Well, that's my best shot at drawing the center of the circle. Now, the angle at the center from x, so the angle here at the center, when I'm taking the starting point as being these x's here, is going to have to be twice as big as the angle at the circumference. So this angle here is going to have to be 2a. This angle here is also being subtended from the same points. This angle here is also coming from x, so the angle at the center also has to be twice as big as that. So if this angle here is twice as big as this one, and this angle here is twice as big as that one, then these two angles must be the same. Okay, so the next... We're back.
Oh, God.
Yeah.
Okay, we are back.
Oh.
So both of them got that question right. Sorry, I didn't send them the screenshots of those videos. So there's a bit of a lag, so we are watching them in the background as you're watching them. So that's one apiece. So the PhD physicist and the professional genius that is Rumpus have a 100% record. Let me just turn that off. Oh, what am I doing? What am I doing? What am I doing? What am I doing? Take that off. There we go, we're back. Right, so question 2 for the chat. If I bring this over, I should be able to do this. And I don't know what I'm doing. Right, question 2 was this one. We have what's known as a cyclic or cyclic quadrilateral, depending on how you want to pronounce it. And we are being asked to find angle B. We know angle A is 94 degrees and angle D is 83 degrees. But what is angle B? Cyclic quadrilateral. I'm going to have a look in the chat, see what the chat make of that. What did you think of that one, Rumpus? Easy or...
I thought it was very easy. It was so easy I didn't bother to write down my answer. I mean, it's just 180 minus 83, isn't it? Whatever that is.
Okay, we'll not wait for the answers from the chat. We'll...
Sorry. I'm sorry.
Yeah, don't worry about it. No, it is because the rule is. Joe, what did you get as your answer?
Yeah, which is 97.
Yeah, because in a cyclic quadrilateral, opposite angles must add up to 180 degrees. Simple as that. So these opposite angles add up to 180 degrees, so therefore this must be 180 minus 83, which is 97. But the question is, how do we prove that? Let me just take that off. Oh my word, and take that off. How do we prove it? We prove it... Okay, next proof. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So B adding to D is 180 degrees. A plus C is 180 degrees. How do I prove that? Again, I'm going to use the idea of the angle at the center being twice the angle at the circumference. So I'm going to draw the center of the circle. And I'm going to draw a line from A to the center and then from the center to C. And I'm going to label this angle. I'm going to call this X. Now, what do we know about X and D? We know that X must be twice as big as D. And even though this angle, is a backwards angle, it's going the other way, yeah, we know that B must be half as big as this angle here, which I'm going to call Y. So B is half the size of Y, D is half the size of X. All right, so let's write that here. B equals a half Y, and D equals a half X. So if I add A and B together, right, so A and B together, A plus B must equal X plus Y over 2. All right, so A plus B is going to be half of X and Y. But what do we know that X and Y must add up to? X and Y must add up to 360. So A plus B must equal 360 over 2, which gives us our 180. Okay,
It's
next
the same.
proof.
It's,
Opposite angles in
quite
a
an
cyclic
interesting one.
quadrilateral. And
Well, I mean, if you
yeah, that's it. But we're back. Sorry, I'm a little bit ahead of you guys. We are done with that. Please take that clip and give it to whoever needs it. Those things. I like those little proofs and stuff like that, but you need to run them over a few times to really get them in your head. Sorry, Rumpus, I interrupted you there. What were we saying, mate?
Oh, that's fine. No, just saying this is very interesting. Those little proofs there that they're not obvious. So, but knowing them is the useful information.
They are. I like them. Joe, do they do? Are you American? Do I detect an American?
yes, I'm quite American. It's true.
And what does this compare to like American sort of geometry at that age, 15, 16-year-old?
15, 16. I think I had this kind of geometry when I was about 14. 15, 16, they usually have us do like calculus and stuff.
Really, you did calculus? You were doing calculus at 16?
I think so. I mean, I was in like the AP classes and stuff.
I mean, I did, but I had to be sort of at the top to be doing calculus by 16. I had to be doing.
My school was very. You could kind of pick the classes you wanted. I mean, I did well in my like lower high school because like American high school, you go from. What do I want to say? About 14 to 18, all in one school. And so, 14 you do algebra and geometry, maybe 15 it's more geometry, and then you can take like calculus.
Yeah, I mean, we do calculus normally for children 16 onwards for calculus, unless you're bright, and then I did a little bit earlier. But you've got this wacky system I wasn't aware of. I mean, in this country, when you're 18, you take your A-levels, and you tend to pick 3 subjects, and then with the result you get from that, you then are picked by. You can then have access to university. But as I understand, in America, you don't have this. You don't have proper end of 18. You have some sort of strange entry to the university exam or something. You only have some middling sort of exam at 18, and then there's some strange entry examination or something.
Yeah. So in America, at the end of high school, if you want to go to university, you take it's called the SATs, which are nationwide standardized test in this like mathematical reasoning, reading comprehension, and an essay section. And you just get a score, and there's no passing or failing. And then universities look at that score as part of the sort of evidence to take you or reject you. And you just apply to whatever universities you want to apply to and send them that score. And then they make
because I think that would put you a year or so behind us. I would have thought at that age, because the detail we go into, say, maths and physics and things, we specialise at A-level level. So we've actually got quite advanced at 18, whereas the sort of more general examinations you're talking about, I mean, you'll be quite a long behind. But then again, you have 4-year degree courses, don't you?
Yes.
Whereas we have 3, so possibly we end up being the same, perhaps.
And we tend to specialize like second year of university. So we don't tend to specialize until about 19 in a university, but then it goes for 4 years.
Right. So, okay.
Assuming you don't change your mind while you're at university or something like that.
Right. Okay. That's the way. I thought it was very. That seems a bit wacky to me, but there we go. Everybody to their own. I mean, I think the A-level system in this country is regarded as quite good. I mean, this is around the world. I think the A-levels are recognised as being pretty good. Standards.
SATs are not so recognized.
Right.
I mean,
Right. Sorry, guys. I've got the next. I've just been faffing around looking for an image. The next question we did was quite tricky one, and it relied on a couple of different rules that we've got. Now, I don't know if you can see the screen at the minute, but one of the rules it relied upon was this one here. If we have a circle and we draw a tangent line to that circle, then a straight line from the center of the circle to the tangent, a radius, will form an angle of 90 degrees with the tangent. That's going to be really important in the question you're about to see. But before I show you that question, let's look at how we prove that, because again, you need to be able to prove all of these things. So here's your quick proof. So the radius to a tangent must be 90 degrees. The easiest way to prove this is to extend this line here. So we have our diameter,
America
we've created
loves
two
us,
semicircles.
right? So
Remember the
just loves them.
semicircle
yeah, there's another
theorem
set
that
of
we've just
standardized
proven.
tests
This
after
must be
university
90
before-
degrees here. And remember the alternate segment theorem. So this angle here to the
That counts.
Yeah, sorry, I was showing completely the wrong thing there. So let's have a look. Let's do that again. Yeah. I meant to show you a different proof first. Tell you what, let's look at the question and then I'll show you how I answered it. We'll do that. The question was this. It was a tricky one. Let's leave it on the screen and then we'll see how you guys think you did. So, questions here. We are told that A and C are points on the circumference of a circle. These two lines here are tangent to that circle. This angle here is 46, and we're asked to find angle O in the centre here. Asked to find angle O. So we'll see what the chat make of that.
Really?
Just while the chat are having a go at that one, how did you two guys find this?
Yeah, I thought this was quite easy. In fact, I found it so easy I didn't write down my answer.
I found I found the angle you actually asked, which was angle A, OAC. I can tell you angle O if you want.
Oh, sorry, it was angle A. My bad. Yeah, sorry, it's OAC. It is angle A. You're right. What? Let's see if anyone in the chat has given us any thoughts on this. No. So.
Yeah, I mean, sorry, Karen.
That's okay. Go on.
I was going to say the way you obviously you have 90 degrees minus. You know that the A and C are two. Those two added together, they're the same thing. A minus 180 minus 46 gives you twice the two other angles. Divide that by 2, you end up with one angle. Then you subtract that from 90 because there's a 90-degree angle at OA. Does that meet at 90 degrees? So you just need to subtract 90 minus half that 180 minus the 2 that, and you halve it. Oh God. I really need to present you with a formula, but I can't remember what I thought it was so easy. I didn't write it down.
I'm going to show a video of how this is solved in a second. Because
Hold on, I think I've got it. Was it 55 degrees?
55? We will find out.
Maybe
for angle A.
Maybe enough. I did write that one down. That may be a different question. I've just given you the answer to.
What did you get, Joe, for angle A?
23 degrees.
23 degrees.
I think
okay, so
question.
Joe says 23, Rumpus says 55.
No, I think I don't have a number. I just have the text in. I couldn't remember if this is the applicable. I think it might be the next question or the one after that.
Well, what I'm going to say for... Let me just move that.
I can quickly do it now. Hold on, I'll do it now.
Okay, do it while the answer's on. I'll show you a video of how I answered this and the rules that we used when we answered it. I made a mistake in this, and what I've done is I've edited the video to leave my mistake in. I could have done it again and took the mistake out. A simple addition mistake, which hopefully you'll spot. And I've left it in just to show you that it doesn't matter how confident you are and how well you know your stuff. Always go back and double check your working. Always go back and double check your working. I did, and I found my mistake. See if you can spot it. But anyway, here we go. Here is our answer. This is question 3, isn't it? Which means that whatever angle O is, I need to be able to add 46 to it to get 180. So I know that angle O here is 134 degrees, right? I know this is 134. Now, I can concentrate on this little triangle here, this internal triangle. I know that this side is the radius of the circle, and I know that this side is the radius of the circle, so they're going to be the same length. Again, I've got an isosceles triangle with this being 134 degrees. So what does that tell me? It tells me that this angle here and this angle here must be exactly the same. And this plus 134, because it's triangle, must add up to 180. So in other words, both of these added up together must add up to 44 degrees. Because 44 plus 134 gives me 180. But they also have to be the same because it's an isosceles triangle, which means that angle A here must be 22 degrees. Which means that... Okay, We're back. I don't know what happened with that one. I pressed play and it showed the second half of me explaining it and not the first half, so I apologise. But the answer was 23. So well done, Joe. And Rumpus worked it out while that was on and also got 23. So they have got 2 questions
Should we talk about how to do it? Or
I did try and describe it earlier, but I need to. I was actually trying to draw diagrams actually of the answers here, so I could explain how I'd done it. And because that took so long, I didn't then answer all the questions.
Should I try?
Yeah, go ahead, Joe.
Put this back on screen, Joe. I'll hover my mouse where you want me to hover my mouse, and you tell me how you did this.
So you can cut this angle ABC in half, and because they're tangent lines, you make 2 right triangles. And you know that that's 23, and then you can get angle O. And then by 90 minus 23, the interior angles add up to 180. Once you have angle O, you have this isosceles triangle in here, and you can get the other 2 angles.
So what you're saying is you put a line down here to split into 2 large right angle triangles,
Exactly.
knowing that this has to be 90.
Mm-hmm.
And then you use trigonometry to figure out angle O. And okay, that's...
I didn't do it that way, I must admit. That I did it a different way. I just simply used the sum. I just kept on... I was always using 180 minus 2 times the other 2 angles, because I knew they summed to 180. And then I kept on just subtracting that, and then eventually did 90 minus the one of those angles, half.
Well, the way I did it was to look at this larger shape, this kite shape, as a quadrilateral, and all the angles here must add up to 360 from B to A to O to C. I know that A, because that's the tangent, using the circle theorem, we've got the radius to the tangent. A is going to be 90 degrees, C is going to be 90, B is 46, so I could figure out angle O by subtracting all of those 3 from 360. And once I knew what angle O was, I then concentrated on this little internal triangle, knowing that the other 2 angles must take angle O up to 180. But because it's an isosceles triangle, both these sides are the radius, I split it in 2 that way.
Okay, so I give my way. I give my way again. But if you can move the pointer to the, so if you move the pointer to A, if you move your pointer to the point A. Oh, so I'm looking at I'm looking at YouTube. Sorry, yes, it's a bit delayed. So if you, yes, so you move to point A, then you can obviously say angles A and C must add plus the 46 degrees must add up to 180. So therefore, you know that A is equal to half of 180 minus 46. So having got that angle there at A, you then know that that's 90 degrees from A to O to B. So you just simply do 90 minus whatever that is, and then you've got the answer.
We've all got our different ways. I like to just apply the circle theorems as taught. But yeah, I like that. Okay, I'm going to take the display capture off. We'll move that. So the score is 3 apiece. Let's see. I really want to make sure we get through all the circle proof videos. So let's have a look at another one of the proofs. Let's have a look that we want. And we'll show that. Okay, this on screen here is what we call the ultimate segment theory. If I have a tangent line to a circle, and then inside that circle I have a triangle, angle A from the triangle to the tangent line will always, no matter what this triangle looks like inside, as long as it's touching the inside of the triangle, angle A will always equal angle B. Always. Now you need to know how to prove that. So here is the proof. Again, if anyone knows anyone that this video might be useful for, these are the bits that can be cut out. So how do we prove the ultimate segment theory? Well, this is the alternate segment theorem. How do I prove that this angle here is the same as this angle here? Well, I'm not going to do that. What I'm going to do is I'm going to use the angle subtended by the same arc idea. I'm going to place a dot in the center of that circle. I'm going to use that to draw a diameter across the circle, and I'm now going to draw a line from here to the exact same point that this line arrives at. And now what do I know? Okay, remember, angle subtended by the same arc, this angle here must equal this angle here. So I'm not going to try and prove that this angle here is the same as this angle here. I'm going to try and prove that this angle here is the same as this angle here. And then by default, we know that because these two are the same, this angle here is the same as this angle here. What else have I also done? I've drawn this straight line up here. Okay, think about your semicircle theorem. I know that this angle here must be 90 degrees. So how do I use that to show that this angle here is equal to this angle here? Well, how many degrees are there in a triangle? There are 180 degrees. Let's write this here. There are 180 degrees in our triangle. So this angle here, if this is 90, this angle here plus this angle here must equal 90. I'm going to call this angle X. So if I say X equals 90 minus this angle down here, which I'm going to call Y. Okay, X equals 90 minus Y. That's what this angle is. Okay, because remember these two must add up to 90. Well, what have I got down here? Well, I remember that my radius to a tangent, this angle here, must be 90 degrees. So what is this angle here? Well, these two have to add up to 90. So this angle here, which I'm going to call angle Z, why not? Z must also equal 90 minus Y. So if X equals 90 minus Y, Z equals 90 minus Y, then both X and Z must be the same. And by default, therefore, remember the angle subtended by the same arc tells us that X is going to be the same as this angle here. Well, this is the alternate segment theorem. How do I prove that? Okay, so, because I'm getting a little bit confused on operating the back end of this here because I don't know what I'm doing. I've lost track of which proofs I'm showing and which I haven't. So what I'm going to do, rather than try and keep up with the questions, I'm just going to show the proofs now that you need to know so you can clip them all out in one go. There's about 2 or 3 more. You can have those, and then we'll go to the questions where we can see the proofs being applied. So we've seen that proof. This one here now might make a little bit more sense. Proving that the angle of a radius when it meets a tangent is 90 degrees will make more sense now you've seen the angle that we've just looked at, the ultimate segment theory. So I'll play that again and then we'll move on to the other 2 or 3 proofs and then we'll move on to the question. So the radius to a tangent must be 90 degrees. The easiest way to prove this is to extend this line here. So we have our diameter, we've created 2 semicircles. Remember the semicircle theorem that we've just proven. This must be 90 degrees here. And remember the alternate segment theorem. So this angle here to the okay, so we've seen that proof. Are there any, what other proofs have we not done yet, Joe? What can you think of?
So we got you can move the angle wherever you want as long as you don't change the subtended arc. You've got the double thing. You've got the inscribed quadrilateral. You've got that one you just did with the diameter. You've got the tangents.
Got the angles in a semicircle, which is this one here as well. For those watching on screen, if I draw a diameter across a circle, and then from that circle, I create a triangle, as long as I hit the circumference, it doesn't matter where on the circumference, you know, so point C could be anywhere on this circumference in that semicircle, and the angle at C will be 90 degrees. It will be 90 degrees. The proof for this is very similar to the first proof we did about the angle at the center being twice that circumference. But again, I'll play that clip so you can clip it out and show people. Here we go. So angles in a semicircle must be 90 degrees. This is exactly the same as the angle at the center, exactly the same. If we go back and watch the first proof we did in this video, you'll see how just identical it is. Right, this angle here is obviously 180 degrees. This is 90 degrees. The angle at the center is twice as big as the angle at the circumference. But how do I prove that it's exactly 90 degrees? Well, again, go back to the first proof in this video and you will see that we ended up with 360 minus A minus B divided by 2. That was how we described this angle here. Let me just pull that back into view. Okay, if you don't know where this has come from, you've not watched the beginning of the video, go back and get really confident with how this is arrived at again. So, this would be angle A, this would be angle B, based on what we did on that first proof. And what do we know angle A and angle B add up to? All right, once you've got to this section here, we know that angle A and angle B add up to 180 degrees. So this is the same as saying 360 minus 180 divided by 2, and that gives us 90 degrees for this angle here. Okay? So angles in a semicircle. Okay, we're almost there. We'll get rid of that one. There's only, I think, one or two more of these, and then we'll just bash on with the questions. But if you are higher tier and you're sitting the maths, these proofs are, yeah, they're pretty tricky. So hopefully you will get a chance to capture these and use them. So we've done that one. We've done that one. We haven't done this one. So this circle theorem proof is showing that if we have a chord, which is basically a line from one side of a circle to another that doesn't go through the center of the circle, so it's not a radius, it's not a diameter, we have a chord in a circle. If I draw a radius, which is represented by this red line, to the circumference through that chord, it will cut that chord in half. It will bisect that chord. Your proof for that, the perpendicular from the center bisects a chord.
Angle. Yeah.
Next rule, the perpendicular from the center to a chord bisects the chord. So in other words, I've drawn my radius line here. It's perpendicular to this chord. All right, we can see that with the 90-degree angle, and it's going to bisect, it's going to split it perfectly in two. The length of this is going to be exactly the same as the length of that. Let's name some points here. I'm going to call this point A, we'll call this point B for here, and we'll call this point C. So how do I prove that this line splits these two, or splits this line so these two are exactly the same length? Well, I'm going to use the idea of congruent triangles. I'm going to draw these two lines here, which are obviously the radius of the circle. So I know this length here and this length here for triangle A and triangle B are the same. So we have one side that is the same. I know that this length here is going to be the same for both triangles. So we have another side that is the same. And as the question is telling us, right, if this angle is 90 degrees, this must be 90 degrees. We have an angle that is the same. So if I have two sides and an angle that are the same, that fulfills the criteria for congruent triangles, which means that these two must be the same. Next rule, the perpendicular from the center to a chord. Okay, so we have just one left, and then that's the end of these proofs. We can get back to Rumpus and Joe battling out on the questions. And that proof is this one. Tangents from a point coming to a circle will always be the same length. And then that's it with the proof videos. You can download them all, you can chop them together, and then you've got them. Next theorem, tangents from a point are equal length. So this side here and this side here are equal length. How do I prove this? Again, I go to my triangles. I'm going to create a line across the center here. And I'm going to compare the two triangles that I've got. I know that this is the radius of a circle and this is the radius of the circle. So these two triangles here have a side in common. I know that they also have this side in common here that I've just created, that they're the same length. And I know that both of these angles are 90 degrees from the radius to the tangent. So again, we have two sides and an angle, which is enough to tell me that these two are congruent triangles, which means that these must be the same length. Next theorem, tangents from a point are equal.
Okay, yes, that's the one that I was just working out. Okay, but I just suddenly realised I missed some off the end.
Is that we're done? Right, so they're all your proofs, they're all the videos. Take those. We'll now apply that to the rest of our questions, which we've got over here, and we'll see how our two competitors got on. This is question 4, a little bit harder. This time we're trying to find the size of angle BAC, and there's a few of our proofs we're going to have to use to answer this one. First of all, I'll keep an eye out in the chat for anyone who thinks I've got a method or a comment on this, but how did you find this one, Rumpus?
Yes, I must admit, this is one I didn't write down. I had just to work. I think I just worked out just now because I thought it was so easy. I'm sorry. But I think I ended up with an answer, yes, which I've just done just now because I didn't bother to write it down.
And Joe, how did you get on with this one?
I think it was fine.
I don't think anyone in the chat will... Oh, Caesar, thank you very, very much. What's the angle between a space and a comma? I don't know. It's a cute one. Thank you. So what was your answer, Joe, for this?
I got 64 degrees.
Same here.
60
Yep.
64 degrees. You say you got that as well, Rumpus, yeah? 64?
Yep. No, I got
So
that just now.
This is a difficult question, this one. And for me to try and answer it... oops. Let me go back to OBS. I am terrible at this stuff, aren't I? Okay, that for me to try and answer it on the board would be difficult, so I've filmed an answer to that question. Not on the board, I mean like here on like a live stream, so I've filmed an answer to it, because I've got to do lots of drawing on these when I answer them. So here is the answer to that question, and we'll see if Joe and Rumpus were right with 6. So with this question, I'm being asked to find angle BAC, which is this angle here. And again, I'm not going to panic and suddenly try and figure out what angle A is. I'm going to add all the information that the question gives me onto here first. And that's going to help me figure out what angle A is. So what rules do I recognize? Well, I know that I'm told in the question that these two sides here are tangents. They are tangents coming from the same point. So I know they are going to be the same length. I know that these two are both the radii of the circle. They're going to be the same length. And if I imagine this is a triangle and this is a triangle, well, I know that these two triangles already have these two as the same length, right, in common, but they've also got this side in common. So each of these two triangles have all three sides of exactly the same length. They're congruent triangles. So I know that this also must be 26 degrees. So this entire angle here must be 52 degrees. Now, is that going to help me figure out angle O? I don't know. Let's find out. But if I know that this is 52 degrees, what else do I know? I know that these two, because these are my angles to the tangent, must be 90 degrees. And that's going to allow me to work out this angle here. Because 52 plus 90 plus this big angle O here must equal 360. So now I'm getting somewhere, which tells me that this angle here must be 128 degrees. Now, if this angle is 128 degrees, what other rule do I recognize? I recognize that the angle at the center is twice the angle at the circumference. So this must be 64 degrees. So with this... Okay, so Joe and the Rumpus were both right. It was 64 degrees, so well done. I'm going to put the PowerPoint back on the screen, and because we've all done this in slightly different ways, and then Joe and the Rumpus can tell us how they managed to do this one. So
right, you've got it on screen,
guys.
have you? Okay, so
screen, yeah.
Right, so I'm looking at your slide 4. Yes, I mean the way I do it, I always approach these things with triangles and saying, well, the sum of the triangles is 180, and if you know that one of them's 90, which we do with the OCD, because there's a tangent, the definition of a tangent means that it must be at 90 degrees. So we know that OCD is 90, so therefore we know the angle from COD, in other words, near O, must be 180 minus 26 minus 90. So then you then get that angle, which is whatever it was.
64.
64. Then you would now, if you want to use the rule about the arrow rule earlier about the double, it's interesting. It's rather interesting here because if you double that angle, you then end up with 64. But then you halve it again to get the angle at A because we're following the rule of the arrow. So actually, you double it up and then divide it by 2 again. So in fact, you actually have worked it out from determining the angle of OCD. So that's it really. End up with 64. So
Joe,
I didn't
what was
know.
your... Sorry, go on.
Not finished.
Yes, that my answer does not differ significantly from that.
Similar makeup. Right, okay. So, let's just take that down for a second. So far, the Rumpus and Joe have managed to get every single question right. So it's definitely a tie. I think we've got 2 more circle theorem questions, and we're going to switch topic. And this is by far the longest round. The other round should be a little bit quicker, but I really wanted to get those proofs into this video. So, next question is this one here. We have a weird shape now that's kind of half hanging out well, I say weird shape, it's a triangle, isn't it? But it's half hanging out the circle. And we're being asked to find angle B. That's what makes it weird, because the angle we're trying to find is outside of the circle. It's a tough one. How did you find this one, Rumpus?
Yeah, I thought it was reasonably easy. You do need to add an extra line in, an extra chord to help you along. Yeah, I thought it was relatively easy.
Yep, I definitely added an extra line in. What about you, Joe? What did you think?
I did find the wrong angle, but
Which one did you find?
It wasn't that hard. I found C, ACB.
Oh, ACB and not ABC, right?
Yeah, that must have been.
Well, if you know C,
be.
you can figure out B because you just it's a triangle, isn't it? So what would B be if you know C?
You want an angle now, or are we waiting for chat?
Yeah, should we? Well, I'll go with. Let's have a look with the chat. 60, 60, 60 says Darryl. That's always a good guess with the triangle. Go on, Rumpus. What did you get for angle B here?
I must admit, I worked out the same one that he did. But so the actual angle I want is
B, which will just be 180 minus A and C, won't it?
Yeah, exactly. And so I've worked out 119 degrees for the angle of the
the other one.
Yeah, the other one. Yeah.
Yeah, me too.
So you got 119 for C plus a 29 for A. So 119 plus 29 is
No, I didn't. No, I didn't work it out. Oh, actually, I suppose it is the same as C. Actually, yeah. I actually worked it out for the chord, for the angle with that, for the opposite. Oh God, is it like the same as C? No, I don't think it is actually. I worked. I don't know why I stopped there. I think I'd done that and thought I had fixed it.
Yeah, no, I was like, oh, that's the answer.
I got halfway. I got 119 for the angle. If you draw a chord between C and where the other line hits, I worked out the angle's 119 for that triangle. Which gives you for the angle you actually want is 100. It's 180 minus 119. Minus 29. So let me just see what that is. Let me just wait.
I'll let you guys figure out angle B, and I'll just address the chat because I've not addressed the chat. So if I
32.
30. So you think B will be 32? I'll just address the chat while Joe figures out what.
I'm there. My calculator just says 32 too.
32 as well. All right. Well, I'll adjust chat and then we'll have a look at the answers and see whether it is indeed 32. So who have we got in the chat? Let's have a look. C4, hello. So the snark. The snark was so helpful on the last Conspiracy Cats video. You will not believe it would have been totally impossible without the snark. So thank you so much for that. It's well worth a subscription. Is the snark? He wrote my Conspiracy Cats outro theme. C4's in there. Dark Steve, new member. Thank you very much. Where's Wally? Hello, sir. Good to hear from you. Crouching Tiger, Hidden Adam. Wow. Right, have you got any questions for the Rumpus or Joe or me? Like, the next 10 seconds would be a good time to put it in before I show you the answer to the question we've just discussed. And then I think we've got one more circle theorem question, and then we're going to move on to something else. Let's have a look. Poor Riley says, Canix, what's he been up to this time? Oh, just not understanding triangles. Hello, Surf. I never know how to pronounce that name. How is that pronounced, Rumpus? Surf. S-Y-R-P-H.
Sorry, can I read it? Where is it written?
S-Y-R-P-H in the chat. So, it's always there.
Oh, sorry. S-Y-R-P-H. Oh, God, yes. Surf, I suppose.
Surf, yeah. Why not? Surf, yeah, there you go. He's having that. Thank you, Surf. Okay, so we'll go back, and for those people who are watching because you have GCSEs or you thought you had GCSEs, here is the answer. So with this question, okay, so this question here, we can do this in a couple of different ways. It's asking us to work out the angle. Which one's it asking us to work out? That would help, wouldn't it? ABC. It's asking us to work out this angle here. So again, what am I going to do? Well, I'm going to look at what the question gives me, and I'm just going to fill in as many angles as I can before the answer becomes fairly obvious. Well, it tells me that BC is a tangent line. So if BC is a tangent line, then I can draw a radius down here, and I have that angle. I know that angle there is going to be 90 degrees. But I know that this is the radius of a circle, and I know that this is the radius of the circle. These are the same. So again, I've created an isosceles triangle, and if I've done that, That means these two angles must be the same. This angle here must be this. So that's 29. Well, what do these three angles of the triangle add up to? These three angles of a triangle add up to 180. So what is 180 minus 29 minus 29, or 180 minus 58? 180 minus 58 leaves me with 122. So I know that this angle here is 122 degrees. So I've started to populate it with things that I can figure out. Right? I'm not concentrating necessarily on B. I'm just figuring out all the things that I can find in the question. But now I know that if this is 122 degrees, I remember that any angles, see this is a straight line here, any angles that this is split up to here must add up to 180. So this angle here must be 180 minus 122. So this angle here must be 58. So now I'm in a situation where I know this is 58. I know this is 90. I add those together, that gives me 148 degrees. So what's this going to be? Well, this is my triangle, it's 180 degrees. So this must be 180 minus 148, which gives me 32 degrees. So yeah, they were both right. It was 32 degrees. Now, if you're wondering why, when I did that, why I didn't just figure out angle B by subtracting angle A and C from 180, so am I. Yeah, but we got there in the end. That was right. So, well done again, both of you. You did that in less steps than me. I got carried away. You two, you beat me with that one. Okay, next question.
Oh no, I want to hear about Rumpus. How you use the chord to do that? Do we have time?
Yeah.
Okay.
Go on.
Okay. Wait. If you've got the diagram there, I can.
Got the diagram here. Yeah. Tell me what to hover over.
Right. So we're on one. I'm on the number 10, and so I drew a chord from C to the other intersection of the other line where it intersects. So between O and B. So I then had a chord there. So then I had a triangle. And I knew, and using your theorem of one about 90 degrees, the line from A to C to that is then not. We know that that's then 90. So then I worked out, knowing that's 90, then I could work out what the angle between O and this new chord that I'd written was 119. Just doing one. I mean, all my things just involve doing 180 minus a value, and you end up with another value. And so I just did 180 minus 90 minus 29 gives you the angle on the internal triangle of the one I described. 180 minus that gives you the angle of the isosceles, well, not an isosceles triangle, on the other side, and then just simply then it's 180 minus that minus the other with the chord in it. I mean, not having the chord drawn is a bit of a pain, and then you end up with what B is. I don't know whether that's more steps than the other way you did. I was tempted to draw in a radius, but then I thought you were trying. I thought that was I was going more with your previous rules.
Well, it's that simple. Yeah, I've got to admit, I wasn't quite sure what you meant when you said drawing the chord, but I'd be interested to see if you drop us an email with that. It's obviously worked. You've obviously got the right answer. So,
because if you make that chord, you do make a right triangle.
Yes, with the right angle at C.
Yeah.
Right. Well, Bill, you both not let me down again. You are absolutely smashing it. Neither one of you's got a question wrong. I'll just pop into the chat, say hi, and then we'll see what you think of the next one. If there are people watching this who know people that will use GCSE revision, this can be clipped down. This is going to go on a while, obviously, but you can download it. Everyone's got permission to download this, clip out any of the little questions and stuff I've got, give it to people. And some people don't really like revising intensely, but might watch something like this just as a bit of a chat and pick a few things up. We'll see. If I do some more of these in future, I might make them more shorter and intense. I'll see what the feedback is. But anyway, for now, let's have a look at the next. And I think almost the last question on circle theorems, which is this one here. We want to find, and this is a tough one, angle C, which is this angle here, in terms of x. So as an algebraic sort of term involving x, how are we going to express C? These are the kind of questions kids hate. When we look at forming expressions, they don't like that. So if you're watching this is a difficult question. Yeah, it's something that I mean, obviously, not every kid is the same, but it is one of the things that I find people struggle with, questions like this. So this takes a long time to answer, so I'm just going to come to both of you for what your answer was for this in terms of x, and then I'll play my answer to the video and we'll see what you got. So Rumpus, what did you get for C in terms of x?
180 minus half x, I think.
180 minus half x, or minus x over 2, same thing, yeah?
Yeah, I must have. I'd only just worked out just now, because this is the question I'd missed, and this one and the next one I'd only just had a quick look at it just now.
I love the fact you've just worked that out on the fly. That is brilliant. I love it.
It's not too bad, right? I mean, if you're allowed to know about inscribed quadrangles, angle A is
Half x. And then if you know what A is, it's that plus 180 minus A equals C.
Exactly.
Well, let's. You are both right. 180 minus x over 2 is the answer. Let's have a look at what the for the kids who are watching, that they'll need walking through that. So that was a difficult question. This is okay. So this question here, a little bit tricky. There's two possible ways we could do it. We have to find the angle BCD in terms of x. So in other words, this angle here, what is it in terms of x? Well, like I said, there's two ways we can look at it. We know that the angle at the circumference is going to be half the angle at the center. Now, even though, I'm going to call this angle O here, even though this is a reflex angle, that rule still holds true. This angle here is going to be half of this. So let's figure out what this angle is here. Well, this angle must be 360 minus x. So we can say that C equals 360 minus x divided by 2. And what does that give us? Well, that gives us 180 minus x over 2. So we can say that C, if we use that method, gives us 180 minus x over 2. Well, there's another method we could use. We could say that this angle here is going to be half of this angle here. So A is going to be half x. So let me just write that down here. We know that A equals x over 2. But we also know, because this is a cyclic quadrilateral, that A plus C equals 180. So we can say, if A is half x, then we can say that x over 2 plus C equals 180. And then we can rearrange this to say that C equals 180 minus x over 2. They both give us exactly.
I mean, I got it in three lines.
That question you did, like, I'm amazed. Let's have a look. Yeah, fantastic. I
mean, I
love the fact Rumpus just figured it out on the fly as well as we were doing that. So that is your answer. That's how we would answer that one. And I know people I teach they don't like questions like that. So maybe if you're the same, or someone who's the same, they can watch that over and over just a couple of times to let it sink in. We've got one more question on circle theorems, and then we're going to move on to something completely different. We've got a bit more maths and a bit of physics and chemistry coming up. But let's have a look at first of all, actually, let's take that off. Let's have a chat with both of you before we do the next question. Rumpus,
hello.
What's this maths like compared to what you remember being at school?
The sort of stuff we did at O level, which was the same as the GCSE thing, I must admit, I thought our stuff was probably slightly more complicated. I mean, I remember doing things like matrices and transforms and solving simultaneous equations, and this stuff is a little bit easier than I remember at my age. But it's different. As I say, I've never met some of these theorems, and the fact that you seem to have got a little formula where you only need to know these 6 rules, and then off you go. We never had, we never had something as simple as that, for instance. So I would say this was about a year. I was a year more advanced, at least, I think. I mean, I just might be being a bit mean, but
it's interesting you say that, because simultaneous equations, I mean, you get introduced to them maybe in year 8, maybe beginning.
I don't know what that means. I don't know what that means.
I mean, either.
It means a couple
What
of years
age is
younger
that?
than 12, 13.
Oh,
so
right.
So like,
Oh, that's
I
early.
always kind of think,
Oh, that's quite
I always
good.
kind of think that simultaneous equations are easier than these. So it's weird, isn't it? How different people like, different things.
What about matrices and things like solving simultaneous equations? Because we used to have to do things like invert matrices and transpose them and then work out the determinant to solve simultaneous equations. The one I just happened to remember when I was thinking of O-levels, one that I found reasonably tricky was solving simultaneous equations by working out the determinant of a matrix. That was what I remember from O-level.
That's not in there anymore. Certainly, well,
Right.
it's not a method I've heard of. We make both equations the same. We subtract one from the other, and then.
That's a little bit simpler. You're right. Okay, that's not quite another
Sometimes
other.
it's difficult to make the same.
So, for instance, one of the tricky one that annoyed me when I did O-level, I think a year earlier than I should have done. One of the questions I had was 2 overlapping sectors, and I was most annoyed that there were a couple of people who had taken it with me early who got this answer, and I didn't get the answer. Can I share my screen?
Yeah, let's give it a go.
Yeah, let's try that, shall we? Hold on, whoops. This was a little. I don't know whether I'm using up your time here. Let's. Here we go. So, for instance, the one that I remember being most annoying to me when I was. Oh, this is coming up later. That one, but I had most annoyed. I had the two. If you draw two. Have a circle and then you cut this in half.
I've just got to rearrange the OBS to get you in.
Okay.
Okay, there you go.
Right, so here's a thingy. So if I cut this in half into four sectors, so if I do that, oops, that's what I meant to do. And then I do, let's just show you what, so if I just cut that, sorry about this. This just does it always. I've had this annoyance ever since. So there's a semicircle. If I just cut that in half here again. Come on, cut. Right. So we had 2. Let's do this one here. I think our diagram. Let me just get the. Just want the outline. Inside. Right, so the question I had, and let's just invert this. Right, that was the question. It said find the area in here, in the middle. And I thought, and I spent about 10 minutes, and this is part of exam technique, the people you presume you teach exam technique. I spent time in these damn things, and I'd get stuck. And I would then stick on a problem instead of go past. Say I've only got 5 minutes to spend on this, and then go on to the next question. I'd get stuck, and I know I can do this. I know I can do this, and so I was stuck on this bloody problem, and it nearly caused me major problems in the rest of the exam just to find this out. And of course, and other people then got it afterwards, and I was going I was been really resenting ever since. And of course, it's these 2 things, and so you subtract. It's the different. You could work out the area of these 2 things separately. And then you just need to subtract them from the square. Is actually the answer? But God, I just couldn't see how to do it at the time. That's just something I remember from my first O-level, which was my first GCSE attempt, which as I say took a year early. That just resented that not being able to think logically and then spending too long on it. So anyway, that's my little O-level story, stroke GCSE thing. That's the sort of thing I remember being difficult.
That's a useful exam technique tip there. You've got to think about marks per minute on the exam. And nobody likes to skip a question, but if it's taking more minutes than the marks are worth, move on and come back to it. Exactly. Right, we'll do the last one. Can I have my screen back?
Yep. Okay.
Rumpus is
just stop. Hold on.
then I can rearrange the OBS.
Sorry. How do I stop?
PhD Tony is in the chat. Ignore that. I'm being surrounded by the most intelligent men on the internet at the minute.
I've never used it. Where's the sharing bit on this gone? Stop screen share. There we go.
Maybe not. There we go. Yes. Okay. I how do I do that? So let's just trim this.
It's quite impressive, though, to go and use a completely new conferencing system we've never used before, Cats, and this thing.
Yeah,
Selecting
I do like this. Mr. Sensible put me onto this. It was, and it's free. It's called whereby.com. So, Joe, last question on circle theorems for you.
Mhm.
What am I doing? That's what I'm doing. Let's turn that off. Was this one? Should be very, very straightforward. We shouldn't need any video explanation for this one. Angle X. We have a tangent line, DC and E. Angle X is the tangent to the triangle inside the circle. What is angle A? Or what is angle X even?
What is angle X? I mean, you proved this. I'm waiting for it to come up on the YouTube feed. You proved in a video, I think you showed a little before, that angle X is going to be the same as angle A.
Mm-hmm.
And then you just, angles in a triangle add up to 180, and you get 46 degrees.
Fantastic. Rumpus, I'm assuming you got exactly the same with that one. That's
Yeah, so that was easy. Yeah, that was just following on from that basic rule, wasn't it? The what's it rule about segments or something?
Which I had.
Was it alternate segment rule? I think you called it, didn't you?
Yes. So the next ones are. We're going to operate this next one differently. I'm going to ask one of you for your answer, and not the other one. And it'll just be, if you get it right, you get a mark. And then if I ask the other one, they get it wrong, they don't get the mark. But we're going to start here with surds. Now, this is something that people in the chat should be able to do quite quickly. So I'm asking you to write root 48 in the form of k root 3, where k is an integer. Joe, that's going to be your question that I want the answer for. Question 1 there. 48 in the form k root 3.
K
Rumpus. Sorry, yeah. Rumpus, I want you to do that one.
The second one. Sorry.
The second one, yeah.
Right, second one. Okay.
Now, before we do that, in the chat, just if you want to play along, I'll give you maybe 10 seconds to get a pen and a pencil and just write down one or two of these questions, because I'm going to take it off the screen in about 10 seconds. And then we'll see if anyone in the chat beats you. And then I've got a little video that will just explain to the kids watching that aren't quite as advanced as you two what basically these questions mean. For those people who were just being introduced to surds or were pulled out of school because of, at the point before you'd learnt them, just a nice little introduction. And then we'll go to some of the harder questions, rationalizing the denominator and whatnot. So I'm going to pull these off the screen pretty quickly. They've gone. In the chat, if you wanted to play, feel free to... What am I doing?
Can I have 10? I'll be back in 10 seconds.
No problem.
What did you call these? Surds?
Yeah, now you might be able to help me out with this, because I mentioned that to someone on a Twitter group, and there was an Canadian maths teacher, and I was talking about indices and surds, and she said, no, you mean exponents and radicals.
Yeah.
And is that what these would be?
Means. Never heard of this before.
So essentially, irrational square roots is how we'd. PhD Tony says 4 root 3 and 5 root 2. I am not going to argue with PhD Tony. He's a professional mathematician and just an all-round genius. So if I can't remember what I got as my answer in the video, but if it's different to what PhD Tony's got, I'm going to cry. So yeah, what do you call them in America?
I don't know of a category for this kind of problem. I mean, this is just algebra problems.
Yeah.
Of various kinds. So yeah, but radicals. I mean, roots are, we call that a radical, and then exponents are, when you exponentiate things.
So essentially, yeah, indices and surds is what our kids know them as, and that surprised me a little bit, because I mean, I'm not a professional mathematician, obviously. My degree wasn't in maths, my degree was in science, and it never occurred to me that mathematical terms would be used differently by people who speak the same language, But maybe someone in the chat can elaborate on that. George, is in the chat, George Natiuk, and I always get that wrong. I'm sorry, I didn't do that on purpose. Surd is a special form that involves radicals. So, same. Now, let's go with your answer anyway. You had question 1, Joe, which was, if I put that back on the screen.
S-U-R-D. Okay.
Question 1, which was yours, was root 48 in the form K3. What was your answer?
I got 4 root 3.
You got 4 root 3. Rumpus, you had root 50 in the form K2. What did you get?
I had 5 root 2. Is that the answer? Yeah, 5. 5 root 2, I think, was the result.
Yeah,
well, so K is the value of 5. K is the value of 5.
I can tell you, I think you're both right. Obviously, I mean, like, who am I to correct you two with your level of maths? But this is how we would, if you're watching and you're a child at home, you don't really know what we're talking about with this. I've done a little video here for you just to explain when we're simplifying surds how to get started. All right. So this will be kind of like your grade 4, grade 5 kind of simplification. And then we'll get a bit more complex. This is just how we get started, and it includes the answers to these 2 questions. Right, so let's just remind ourselves to start with how we simplify a surd, and we'll just start with root 8t as an example. The first thing I'm going to ask myself is, how many different ways can I write down root 8t? I could obviously write it down as root 8t. I could write it down as root 10 times root 8. That's going to be the same value. I could write it down as root 2 times root 40, again the same value. I could maybe write it down as root 4 times root 20. All of these hold the same value as root 80. But being able to simplify surds means looking for numbers that we know the square root of. I don't know the square root of these. But look, I do know the square root of 4. So root 4 times 20, I know the square root of 4 is 2. So I can actually rewrite this as 2 times root 20. Now, I'm not done yet. I'm not finished. Because actually, I could rewrite root 20 as root 4 times root 5, couldn't I? And again, I know the square root of 4 is 2. So I could end up with 2 times root 5, which gives me 4 root 5. But in this question here, we're being asked to simplify root 48 as k root 3. Now, in the last question, we had 4 root 5, and 4 would have taken the place of the k in that question. This is just going to be the number that we have, that we're going to multiply our surd by. But this question's doing us a favour, because it's telling us that when we write down root 48, when we change the way we write it down, one of the numbers underneath here is going to be a 3. So, what number am I going to multiply 3 by to get 48? Well, that's 16. So, this is telling me it's going to be 3 times something, gives me 48. So, I've got root 3 times root 16 equals 48. And because I know my square roots, I know the square root of 16 is 4. So, I can rewrite this as 4 root 3. And that's my answer, okay, in that format. If we look at the part 2, we had 50. To be written as k root 2. So I know that when I'm rewriting this, I'm going to be rewriting it with a 2 times something. So I have root 2, and that has to be times by root 25. So root 2 times root 25. And I know the square root of 25 is 5. So that gives me 5 root 2. Right, so let's just remind ourselves to start with. Pull it back in a second. Okay, so they both got that right. I know in the chat, I'm looking out today. We've got PhD Tony, we've got George Hnetyuk, we've got Jen's little corner, who I was on her stream the other day, and incredibly intelligent. Very, very impressed with her. Really, really amazing stuff. I've got PhD physicists next to me in the chat. I've got the Rumpus here. Amazing. So inundated with people that really know this stuff. So that's question 1. Again, it's a tie. Not one of you have got a question wrong yet. So you're both tied. Question 2. Let's try and make things a little bit harder. Why is my screen gone all funny like that? There we go. Let's make things a little bit harder. And it's not even that hard, I'm going to be honest. This is going to be your question, Joe. Write 3 plus root 5 squared in the form a plus b root 5, where a and b are integers. So that's going to be yours. I'm going to leave that up. I'm going to have a look in the chat in a second. Anyone who's got a pen and paper wants to play along, hopefully you've got that written down now. 3 plus root 5 squared. Essentially, you're just going to simplify that. I'm going to take that off now. And anyone in the chat can tell us how they did. Let's have a look, see who else is in there. PhD Tony says it's attempting to approach this from the direction of prime divisors. You know, there are teachers that teach it that way, and it is, I think, a slicker, more methodical approach. So yeah, I won't argue with that for a second. Right, Joe.
So my question's number 5. Is it the next?
Yeah,
slide
yours is
3
going to be the
my
next one. We're going to see if Joe can get his right first. So the question was, if I remember it correctly, it was write 3 plus root 5 squared in the form a plus b root 5. Your pal Al says 14 plus 6.
You mean the two integers are 14 and 6, and then there's a root 5.
14 and 6 root 5.
Yeah. Which I agree with.
Okay, so you say 14 and 6 root 5. What I'll do is I'll play the answer to that question, see if I've got it right. Again, if I've not, I'll cry. And then Rumpus, it's your turn. How did you do it, Joe, by the way, that one?
I just did, write 3 plus root 5 in parentheses twice and duet multiplication.
Expand and simplify.
Yeah.
Okay, so if you're watching and you don't know what's going on because you haven't done surds yet, or you've not finished surds, this is how I'd answer that. So the next question is asking us to simplify this, and to simplify it in the form a plus b root 5, where a and b are integers. And you know what? Whenever you're given a question and you're asked to simplify it in a certain form, I never really look at the end goal until I've finished the question, because just by simplifying this, it will lead you here, right? If we simplify this properly, by the time we're done, it will give us what the question is asking for. They're not trying to trick us. So how do I simplify this? Well, I've got to square it all to start with. But what I'm not going to do is fall into the trap of saying, oh, if I'm going to square this, 3 squared is 9, root 5 squared is 5, so it's 9 plus 5. That's not how we do it. Remember, 3 plus root 5, we've got it in brackets here. This is one number. And how do I square a number? I multiply it by itself. So I have 3 plus root 5 multiplied by 3 plus root 5. Oh, my word, I can't write, can I? 3 plus root 5. And how am I going to multiply them by each other? Well, it's simple. You could use a grid method if you use that in school. But very simply, 3 times 3 is 9. 3 times root 5 is 3 root 5. Root 5 times 3, again, is 3 root 5. And then root 5 times root 5, well, any root times itself, we just get rid of the square root and we get 5. So, let's simplify this. Let's sort my root 5s out first. I've got 3 root 5 plus 3 root 5. That gives me 6 root 5. And 9 plus 5 gives me 14. So I've got 14 plus 6 root 5, which just coincidentally leaves... Okay, so you were right. Brilliant. Everyone in the chat seemed to nail that really, really well. The Rumpus, your question is coming now, sir. Let me...
right to you.
And we are here. Now, this might look easier than the question that's just been had, but there is a very specific reason I've chosen this question. It for the kids, it certainly comes in handy at other points. So that was your question. Expand and simplify. 2 plus root 3 times 2 minus root 3. If you're playing with pen and paper, hopefully you've written that down by now because it's coming off the screen in about 10 seconds. So 2 plus root 3, 2 minus root 3. It's now coming off the screen. And Rumpus, what did you get?
7.
Okay. I'm starting to wonder if I've done it wrong now.
Okay.
Did I make a mistake on the video?
Hold on, let me just check this. I've just got. This is actually something I have written down. Let me just check I haven't done something stupid. You're worrying me now.
I get the same that Sacrifice. What a name! What a name that Sacrifice. That's I love that. Sacrifice your palal, huge arse. Where can I find?
Isn't it 7? Is it 7? Is it not 7?
I think I got 1.
I got 1.
I will play the video and have a look on the watch page. See if you think I've gone wrong, because I know you're way better at maths than me. So
I must admit, I only spent 2. I just looked at it and I thought I recognised that structure, and I just put down an answer. I must admit, I didn't check it at all.
Well, this could be Joe taking the lead.
Damn, I did.
Let's have a look. I'll play the answer, and again, if you're in the chat and you're working away, these will seem really easy to you. But
oh, sorry. Yes, there's a minus sign. Sorry. Yeah. Sorry.
You squared the 3.
Yes. Sorry. Yes, there's one minus signs. Yeah, I knew it's a squared minus b squared. I did a squared plus b squared. Yes, indeed, it is 1. Yes.
Cool. Well, here's how you would answer it if you're not sure. But yeah, I'll give you the benefit of the doubt at Rumpus. You get.
Oh, thanks.
Yes, that's okay.
Don't worry, you'll get the same later. On the tiebreaker, I'll be kind to you. Now, this question here is also asking me to expand and simplify. It's not giving me an end goal to get to. It just wants me to expand and simplify, which we'll do. But I want to point out something interesting about these two brackets. They look identical, apart from the fact that one has a plus and one has a minus. And your teacher in school might use the term difference of 2 squares. But let's have a look. Something interesting happens when we have 2 brackets that we're going to expand here that are the same, except one has a plus and one has a minus in it. So let's expand this. 2 times 2 gives me 4. 2 times minus root 3 gives me minus 2 root 3. Root 3 times 2 gives me plus 2 root 3. And then root 3 times minus root 3 gives me minus 3. So when I simplify this, what do I notice? I notice I have a minus 2 root 3 and a plus 2 root 3. They cancel each other out. Okay, there you go. Just leave me with 4 minus 3, which gives me 1. So all of this has a value of 1. Now, why is this interesting? Well, when I have a plus and a minus in these brackets, I lose the surd. It disappears. It goes. And that's going to become really important for one of the questions we're doing later on. Okay, just
come up.
Now, this question here is also
in
asking
various quadratic problems where you need to factor something looks nothing like this into something that looks like this. It does come up when solving different kinds of quadratic equations to factor something into 2 factors that look like that.
Right. Well, thank you. Thing is, we are all level. Let's have a look at the next question, shall we? And the next question, display capture. This is going to be yours, Joe. Unfortunately, Rumpus gets the hardest one. Rationalize that denominator. 6 over root 3. I'm not going to leave that on the board God, I'm going back to your teacher. I'm not going to leave that on the screen for very long. 6 over root 3. I will take that off now. So rationalize the denominator. 6 over root 3. Let's see how the chat are doing with that one. And we will see. Rumpus, don't give the answer away to that question, but would you have got that one? 6 over root 3, rationalise the denominator.
Oh, yeah, I got that one. Yeah, got that written down. I've even got that one written down.
And I have a feeling I didn't fully simplify on my video, actually.
What did I end up with? I ended up with 2 root... Sorry, did I end up with 2 root 3?
Oh, okay, Joe. So what was your answer?
Let me have a... Oh God, I'm trying to work out the last question because I haven't done the... I really ought to have prepared this a bit more. I'm having to do a lot of this stuff and now. Let me just go back to what's this question again? 6 over root 3. Rationalise the denominator.
Yeah, it's Joe. Don't worry. This one's Joe's question. You get the next one. Joe, what did you get as your answer?
Yeah, I got 1 as the denominator, so 2 root 3.
Yeah, 2 root 3. That's what I said. Yeah.
Yeah. When I've done,
Yeah,
I'm going to play the video. I'm going to play the video for those watching. But for those watching, what I've done is I've rationalised. Next question, rationalising the denominator. For those watching my video, I've rationalised the denominator. I forgot to go on the simplify. I'm going to be absolutely honest. I'm sat here now thinking, why didn't I go on and simplify that? Of course you should always simplify. I was so intent on how do I explain rationalise the denominator, I've not gone on and simplified. And I've got a feeling I've done that on the possibly next question or not. I don't know. But anyway, let's play the video. Now in this next question, rationalising the denominator. What I want to do is I want to get rid of the surd from the denominator of a fraction because it makes them very, very difficult to deal with. How am I going to do that? Well, before I tell you how I'm going to do that, just let me show you something else. Let's take another fraction. Let's take a half. Now, I'm randomly going to choose a number, let's say 3. And I'm going to multiply the numerator and denominator by 3. That gives me 3 over 6. Let's randomly choose another number, 5. Multiply both of those by 5. That gives me 5 over 10. Randomly choose another one, let's say 4. That gives me 4 over 8. And what you'll notice is, as long as I'm multiplying the numerator and denominator by whatever random number I choose, all of these still have the value of a half. 3 out of 6 is a half. 5 out of 10 is a half. 4 out of 8 is a half. They're all equal to 0.5. I've not changed the value of the fraction, even though I've multiplied both the numerator and denominator by a number, as long as I multiply them by the same number. And I can use that idea here. I can find a number that will remove the surd from the bottom, and as long as I multiply the numerator and denominator by that number, I'm not going to change the value of this fraction. And how we do it is we simply look at the surd and we say, right, I'm going to multiply both the numerator and denominator by, in this case, it's going to be root 3. Why is that? Well, because remember, root 3 times root 3 just gives me 3. Let's just prove that to ourselves, just if we were a little bit unsure earlier on. We know that 5 times 5 equals 25. But how else could I write 5 times 5? Well, 5 is the square root of 25. So I could write root 25 times root 25. Sorry. Poor handwriting. Equals 25. So if I multiply 2 roots together, I can just get rid of the root symbol. So root 3 times root 3 is just going to give me 3. Root 3 times 6 gives me 6 root 3, and now my surds move to the top. That's okay. And there we go. So 6 root 3 over 3, and of course, you then simplify. You divide by 3 to get 2 root 3. So kicking myself for not putting that on the end of that video. And I know that explanation was a little bit slow, a little bit clunky. There's so many really intelligent people in the chat, but again, this is sort of aimed at people that haven't even begun to do surds at school yet, that do need that kind of slow walking through. So hopefully that's helped anybody in that level that gets to see this question. Okay.
Can I show how I did it?
I was just going to say, look, because you did yours in a way more difficult way than mine, I think. So
so I just say that, so I have 6 over 3. 6 is 2 times 3. 3 is the square root of 3 twice. And then you can just cancel out the square roots of 3. And you get 2 root 3 over 1.
Okay. I never would have thought of doing that, but that's a good. That's PhD physics. Matt, that's brilliant. That maybe crushing a walnut with a sledgehammer. I like it. And you are undefeated. You've not dropped a single point yet, Joe. How are you feeling?
Pretty good.
And if you win, I hope you've got some good taunts ready for the Rumpus. Hope you've got some nasty things to say to him.
Yeah, if it goes to a tie break, I've got a problem, haven't I? So.
Yeah.
Rumpus, your question is probably a little bit harder.
It is a little bit harder, and I hadn't done it until just now. That's why I've been distracted in working the damn thing out, and it was not trivial.
The problem with your question is we are given the answer. We have to show that this here can be written as root 3. So is there any way you can screen share and type out or show, or do you want to explain it? How would you show that?
Okay, I'll type it out. I will show. Okay, I'll screen share and what I had to go to.
Right.
I was helped in this actually. I happened to mention this question to George Natyuk yesterday, and I said I'd had a quick go at it, and he said, oh well, that's something to do with using a conjugate, and oh right, and I said, and then I went away and I've only just done it now because I'd forgotten. I didn't realise we were actually going to give you the answers in this thing. I thought we were just going to do it live to do the calculation. So then I said, no, having to know what this, you having to use a conjugate. Then I was away. But even now, even using that now, that was non-trivial. But anyway, let me share my screen then to show you what I've done.
Well, while you're typing it, what I'll do is I'll play the video of how I answer it, and then everyone who's watching can compare. The two. Then you've got time to type it out, if that makes sense.
Okay, I'll start typing now.
I'm going to be honest, Joe. When Rumpus then used the term conjugate, I haven't got a clue what he's talking about. What's he talking about?
I don't know. I don't know what that means.
Yeah, that I've absolutely no idea. PhD Tony, if you're in the chat, can you help us out? What is a conjugate? I've not heard of that.
Conjugates. It's just the conjugate's such a general concept. It's like Hermitian conjugate.
It's not something mathematically. It's not something. I mean, I'm not a. Is this GCSE level now? Hey, yes, it is. This is probably grade 7 or 8.
I think I did this differently as well.
Well, I'm going to put mine on the screen now. I'm going to trust Rumpus not to watch it because he's going. I know he's.
I'm not looking. I'm not looking. I'm just busy typing. I've got lots of typing to do now.
So the next question is asking. Now, in this question here, I'm given a more complicated looking fraction, and I'm asked to show that it can be written just as root 3. But I'm not going to panic. I'm going to realise that this is, again, just a rationalising the denominator question. I've got to do something to get rid of the surd from the bottom. And when I do that, it will work out as root 3, right? It will always work out as the answer it's trying to get you to prove when we start simplifying it. So don't panic about what the end goal is. The question will take you there. So let's have a look here, and what can I possibly multiply both of these two by, to get the surd off the bottom? Well, this is more complicated than the last question. Excuse me. The last question was just simply 6 over root 3, so we can multiply both by root 3, and that will be fine. But here, it's a number plus root 3, and I have to treat all of this as a number on its own. But remember, in the last question, we talked about the difference between two squares. We talked about what we can multiply this bracket by to get rid of the surd. So whenever I have a number plus a surd, what I'm going to do is I'm going to mirror the bracket, but I'm going to change the sign. Instead of it being a plus, it's now going to be a minus. And I'm going to multiply the numerator and denominator by 3 minus root 3. Let's have a look and see where we get with that. 3 times 3 is 9. Whoops, a daisy. 3 times 3 is 9. 3 times minus root 3 is minus 3 root 3. Plus 3 times 3 is plus 3 root 3. And root 3 times minus root 3 gives me minus 3. Now, here we can see the plus root 3 and the minus root 3 cancel each other out. So I'm left with 9 minus 3, which gives me 6. So I know the denominator is going to be 6. I'll just rewrite that so it looks a little bit neater, and we'll come back. Okay, so now let's have a look at the denominator. 3 root 3 times 3 gives me 9 root 3. 3 root 3 times minus root 3. Well, the root 3 and the minus root 3 gives me minus 3. Times the 3 gives me minus 9. Here I've got the plus 3 times the 3 gives me plus 9. Plus 3 times the root 3 gives me minus 3 root 3. Excuse me. So now let's simplify. The minus the minus 9 and the plus 9 result in 0, don't they? So I have 9 root 3 minus 3 root 3, which gives me 6 root 3. So let me put this up here. I now end up with 6 root 3 over 6. I can simply divide the numerator and denominator by 6, or you can think of it as the 6's cancelling out. And what am I left with? I'm left with root 3, which is what I was asked to prove in the first place. So with these questions, don't ever worry about what the end goal is. So, I did remember to simplify that time, and I got mine. I was just looking in the chat, and there's been a few. I was speaking to Joe behind the scenes when that was on, and PhD Tony, I think, would have done it in the same way you'd have done it, Joe. Can you just talk people through that? Because
so I know. So you told me that you're going to get square root of 3 at the end. So I know whatever's in the denominator has to cancel out. So I'm looking in the denominator to get 3 plus square root of 3 somewhere. So if I factor square root of 3 out of the numerator, you get square root of 3 times 3 plus another square root of 3, because 3 is just 2 roots of 3. And then you have these, which cancel, leaving you with the square root of 3. It's the same way I did this one up here, actually, is to factor things to get something that will cancel.
Like it. Do definitely like it. Now, Rumpus, you were going to... Because this was your question. So
Yep.
to level things up, you were going to screen share and
I am,
show us
okay,
how
I'll
you do
screen
it.
share. Yeah, I started off, I was a bit tired. I only started tackling it at 12 o'clock last night, and then I didn't have the... Oh, for Christ's sake.
Hello, Rumpus.
Sorry, I was just got a phone call there. Right, so let me screen share. Hold on, I've forgotten how to... Hold on, let me just try and remember
There
how to
should be a
screen
picture
share
of the
again on
TV
this.
at the bottom, one of the icons at the bottom.
Yep, sorry, I was just being distracted there by...
Don't worry about it.
There we go. Oh God, which one of these is it? Box up.
Just for those watching, I may end up leaving the chemistry until another time, just because we've been going nearly 2 hours now, and we've still, you know, if we did everything, there'd be another 3 rounds to go. So, even though they're quicker, I may just drop the chemistry and just concentrate on.
Oh, give me 2 seconds.
The science. No problem. No problem.
Oh,
See.
hello.
See who's in the chat. Have you got any questions for myself or Joe while Rumpus is on the phone? Just drop.
I'm in the middle of something. Can I ring you back?
I read somebody in your chat talking about the FOIL method, we call it in America. First outside, inside, last, for multiplying 2 binomials together. I've always hated that. Always objected to that.
We tend to do the grid method now. A lot of schools teach the grid method, you know, like Punnett squares in biology.
I see.
Yeah.
And then that fixes what I don't like about the FOIL method, because it works for longer strings.
Yeah, you can set your grid to be whatever you want it to be, and and I like that because as a biology teacher, we teach Punnett squares, so it gives a really good opportunity to reinforce the Punnett square teaching. And kids find Punnett squares dead easy, so they say, "Oh, I can't expand brackets," but then you teach them Punnett squares, and then when they realise it's the same thing, they can expand brackets. It's like, well, what were you struggling for in the first place? You're just whinging. Only kidding.
Nice.
Right.
Can you see my screen?
Oh, can we see your screen? Right.
Yeah, I'm sharing my screen. I think you can see.
No, we can't, mate.
Ah. Let's try. Oh, it's coming up. It's coming up in the whereby thing.
Give it a second.
You're looking. It's coming up in my. It's showing as I'm sharing in the whereby screen here. It says your screen share you. Can you not see that?
No. Oh, he's gone. Right. It'll come back in and try again.
Okay. Right. Share screen. Right. Can you see it this time?
Oh, I can see it. Right. Let me sort out the screen and we'll see whether you can get the mark and level up with Joe. Oops. My keyboard is. Right.
Can you see my window now?
Yeah, I can. It's just my.
You need to rejig the OBS, right?
I just need to rejig OBS. So. Look at this. I'm doing this on the fly. Right. Look at that. Okay, we'll make it big and talk us through it then. Go on.
Right. So here's the formula that we're presented with. So there it is. And then if you multiply it by the conjugate, which
Go on,
did you say something? So then we multiply both the top and the bottom by the conjugate, as I'm calling it. So 3 plus the, because the problem is you always want to clear out the denominator of things, and so we happen to know from the rule we did earlier, the whatever it was, this difference of two squares, that if you multiply, if you have a thing with the plus and the minus in there, you get the result of the two squares. So that then means that this will go to, I didn't get round to typing it all out, I'm afraid. That means that if you, the 3 squared, that means on the bottom, let's copy this bloody thing.
I think you've done it exactly the same way I have. I think that's what you've done. Yeah.
And so the difference here, that becomes the difference of two squares, which is 3 times 3 is 9 minus 3. So because if you do the if you have in other words, it's a standard thing that a plus b times a minus b, you end up with a squared minus b squared. So we then square the 3, square the minus the square of that thing. So it's 3 times 3, 3 squared minus square root of 3 squared, which is 3. So end up with 9 minus 3, which is equal to 6. Yeah. And then if you do the rest of this, that after quite a painful, if you then multiply that out, it goes to you end up with 9. God, it's quite a messy. So in comparison to if you multiply this out here, just copy it again.
It simplifies to 6.
It simplifies to. I only put the result in because it's a hell of a lot of typing actually. It's a hell of a lot of typing because I did just as I was working out while you were discussing other things. It turns out to end up with, I'll put the intermediate result of 9 square root of 3. Oh, come on. Go up there, you bastard. 9 square root of 3 minus 3.
Yeah. Square
root of 3 minus 3 square root of 3. Squared. There's a square in there. Oh, so this one's become squared. Oh, I'm not doing a very good job here. Anyway, the end result is that gets to, you end up with 6 square root of 3 all over 6.
Yeah, 6 square root of 3 over 6, and then that simplifies through.
And then you end up with a. I don't know where that's come from. That's done something weird there. And then you end up with 6. Why has that become so stupidly small? You end up with 6 square root of 3 over 6. Yeah. So that all simplifies to 6, and therefore you end up with the square root of 3 being the result. God. Oh, the typing.
Okay, can I have my screen back? I'll see if I can fit us back in. Guys, I'm conscious
but I'd just like to say I deserve an extra point, I think, for doing that.
It was a tough one.
The trouble is Joe also answered it, the little devil. So
you get extra points for doing it the hard way.
Yeah, exactly. I did it the hard way, so I must get something there. I tried to tackle this at 12 o'clock last night, and I thought, God, this. So I didn't see this. I
did the last chemistry problem late the other night. It was bad.
I'm going to need the screen back, guys. I'm afraid.
I've stopped Didn't I stop sharing? Oh, okay.
Right, there we go. Right, and Rumpus is gone. Where is he?
No, I'm still here.
There. Right. So let's bring things back. So I think that is the end of the surds bit. I know I said there'd be loads of rounds, but I'm conscious you guys have already given me 2 hours of your time, and so what I'll do is maybe just use the momentum round as the last round. And then maybe just include those resources I've done in other things, because you've given me a lot of your time already. I really appreciate that. Okay, make this look nice and pretty. I'll just say hello to the chat. We'll move on to the next round. Any questions? I can't see anyone tagged in. Was that so? That's what you call the conjugate, is it then, Rumpus? Doing the what I did. Is that?
Yes, I mean that was a term that George mentioned to me when I haven't checked, but I understand that's if you ever do complex numbers, which perhaps I don't know whether you've met that, any of your kiddies have your pupils have met this, but there's a complex, the square root of -1 leads to this whole, which is used throughout. I mean, Joe there would have used that all the time in his PhD physics, and same did my physics degree. You're using. And Schrodinger's equation, all to do with quantum mechanics, all revolves around, and even messing around with electronics, capacitors and inductors, you need this little I thing, and all wave equations revolve around it, and that's the square root of -1, which is I. And quite often, to deal with problems like the one where you've got a denominator with the I in it, this square root of -1, you need to get rid of that. You need to get it up the top, and you do that by multiplying. And the number comes in two forms. You have a real part, so normal real number like 1 or something, or 5, and then you have an imaginary part. In other words, it's a number multiplied by I. To get rid of that in the denominator, you multiply it by the negative with the imaginary part negated, and you call that the complex conjugate. So if you have x, if you have a plus ib, where a and b are two normal numbers and the I is the thing, you multiply that by a minus ib on the denominator, and then that moves and that clears up the denominator, and then you end up with something on the numerator instead. So it's a very standard technique, and that's why perhaps that's where the name comes from. But I hadn't heard it used for that. I always thought of it in complex numbers, but I just happened to mention that to George yesterday, and he mentioned that he called that a conjugate, so I'm calling it a conjugate here.
Well, there we go. Right, the next one is something that I've put on for the kids because this is again higher level type of question, and it's the type of question that it's a problem solving question. And when I say every single question is different, what I mean is the way that you approach every single question is different. You know, if we got like a a simultaneous equation or factorizing a quadratic or whatever, you know, the way you approach them is going to be the same at GCSE. These are not going to be the same. It's algebraic proofs, and the first time you see an algebraic proof question, the kids hate it. But there are certain skills that are always embedded in this type of question. I'll show you what I mean, and we'll have a look at what those skills are, and then, oops, what have I done there?
Just a quick return to the chat while you're doing something else, Cats. Yeah, PhD Tony's just confirmed that the conjugate of A plus the square root of B, it's to do with, I think it's a surds case where you end up with you've got two terms, one without the radical in it, one with, and then you then the conjugate, that's simply the minus the other radical bit. So the complex conjugate is a special case of conjugate.
Mm-hmm. Oh, right, because it's the square root of -1. Nice.
I'm just going to switch PowerPoints over for
together.
Sorry, right, we'll just get rid of that.
Shoot.
Oh, what am I doing? Let's stop. Capture. So, I'm just trying to get the question up. Sorry, guys. Slideshow. Sorry guys, I need to figure out how to set this up properly, like I had a minute ago. Set up slideshow, that's the button I'm looking for. Browse by an individual window. Okay, right. Slideshow from beginning. And here is the question I'm after. Right, sorry about that everybody. So, Joe, this is going to be your question. And you're going to have to talk me through this step by step. And I have laid out the steps on this PowerPoint that I'm hoping we've done the same ones so everyone can see. But you sit down, you open up your paper in front of you, and it says, prove that x plus 10 squared minus x plus 2 squared is divisible by 16 when x is a positive integer. What do you think of that one?
Okay, so what I do is I expand those two squares and just hope it makes sense after that.
Okay, so the first, now, and obviously you know way more about maths than I do, but I'm just going to explain to the kids that might be using this the key skills. So you've mentioned expanding the brackets, and when you're given a question like this, an algebraic proof, as long as you can expand brackets, as long as you can simplify, as long as you can factorize, Don't be put off by these questions, right? Joe has just said exactly what the mindset you need to have. He's just going to he said he's going to expand these brackets and then just see where the land lies. Okay, so we'll expand these. Remember, if x plus 10 squared is x plus 10 times x plus 10, and we're going to minus x plus 2 squared, which is x plus 2 times x plus 2. You crack on there, Joe.
Right. So when I do that, something that looks like this, right? This.
Can you read it out? I can't see while I've got you covered up. Can you read out what that would be?
Okay, the x squared plus 100 plus 50x minus x squared plus 4 plus 4x. This is how I like to do my squaring binomials.
So you've jumped ahead and simplified perhaps even more than I have here. These are the brackets expanded on the left-hand side.
Yeah,
We're going to subtract from that these here.
I did skip that step.
So you've done the subtraction. Any kids watching, it's important that here you do have all this in brackets, because everything on this side is going to be subtracted from the left-hand side. If we don't have brackets involved, it's very difficult to do that correctly.
It's
okay,
this,
so make sure you've got those in brackets.
What I'm seeing on the YouTube thing right now is what I skipped to.
Right.
Because I always remember, if you square a binomial, you get the first term squared plus second term squared plus twice the cross product. The two terms multiplied by each other.
So when you simplified all that, what did that come to?
We come to 96 plus 16x. And then I actually did it. There's two different ways to go from here.
Can I just jump in a little bit? One of the things I learned about this sort of age was how deadly minus signs are, and I've still got a huge respect, myself and George included. We're both scared of minus signs because we always forget to, we don't put, particularly if they're attached to a bracket, we always forget to use the minus sign or minus signs. Basically, I think if we could have maths without minus signs, it would be 10 times easier. But because we got them, they always screw you up. There's always an error with not including a minus sign in a bracket. I find in all the calcs I do. I don't know if Joe finds he's got a reverence for the minus sign, fear of the minus sign as well.
Oh, absolutely. I mean, just doing this the other night, I had to make sure to write these parentheses in. Yeah. Because otherwise, I'm going to say minus x squared plus 4, and that's going to be over.
Yeah. It just gets you every time. So now I was in preparation. I was hoping that I was going to get a little alert sound so I could mention the minus sign. I was going to go siren noise, because whenever you see that next to a bracket, your mind has got to go off and say, "Oh my God, I'm in dangerous territory! Danger, danger, Will Robinson!" And you've got to make sure and you check that line 15 times before you then carry on, because you're going to miss that minus sign out.
So easy to miss, and miss one, and then it's 2 pages later. And
oh yes,
10 is equal to 15.
That's right, and the thing is, as you say, it's 10 pages later, and you suddenly then have got 10 pages to check. And you've no idea where the bloody error is. And so you've really, whenever you do a minus sign with a bracket, the thing to do to save yourself time is to check that line, that one line, 2 or 3 times. Don't try and find you've got a problem 10 lines later or 2 pages later, because you have to do everything, and it's just an absolute nightmare.
It's bad.
Definitely good advice. I mean, GCSE, what I'd say to the kids is you solve what's inside that bracket first, and you simplify as much as you can, and then just get shut straight away.
Yeah,
but you are down to 6.
If you can do the brackets first, or distribute the minus sign and get rid of them.
Yeah. My other favourite failure is when I am faced with a complicated thing, brackets, and it's in the middle of the equation. I solve that and I think, oh, thank God I've done that properly. And then I forget to do the rest of the equation on the next line. So I just then go straight to doing the next line. That's my other 2 failings I have in maths. One is not getting minus signs. And then when I do have a complicated bracket to expand, I then forget. Something like this. If you were busy solving something on the left, the first one, if I've had a really complicated brackety thing, and I think, you get to the end of solving the insides of the bracket, and you think, I finished that line now. And then you jump down to the next line, forgetting there's a bit more on the end. That's my other failing.
Yeah.
So be
All right.
careful
So what-
about doing your brackets inside. Make sure you don't forget to do the rest of the thing.
Mhm.
So once you've got to that point, 16x plus 96, how, obviously it's fairly straightforward, but how would you prove that it's divisible by 16?
So what I need to show is that it's 16 times an integer. I think you told me x is an integer, so I got to do an integer times x. You can either factor out 16, and then you're left with something that's an integer, or like the really dopey way that I did it first is check that, 16 is obviously divisible by 16. Is 96 divisible by 16? You just do that division, you get an integer, so that whole thing has to be divisible by 16.
I would like to get some extra points that Joe's not that. I would say you end up with an equation of is it something like 16 brackets x plus 6 or something.
There we go.
And therefore, and that is the full simplified thing. And I don't think Joe simplified it fully, so I think I'm gonna claim my.
He did say you could factorize it. He did say.
Yeah, but he didn't know, did he? He didn't know.
What's that, Rumpus? What's that say right there?
I'm gonna give.
Oh, sorry. Oh,
give him
okay.
a
I
mark
can't.
for
So I'm
that.
looking at what Cat's doing. Sorry. Say it again, Joe. I missed that.
What's
You
that?
actually-
What's that right there? What's that say?
Oh, your screen's not updating for me. Oh,
Yeah, I'll just leave it there for a bit. But it says
I'll give-
16 times 6 plus 6.
oh, okay. All right then. Okay, I take that back then.
I'm definitely going to give
Damn.
him a mark for that one.
Damn.
For anyone who the kids are watching or anything like that, the skills in this are: can you expand brackets? Can you simplify? Can you factorize? And as long as you do that, not a problem. It becomes a little bit harder though when you're not given the brackets. You're not given any kind of algebraic expression. When you're given something, and this is your question, Rumpus, when you're given something like
God.
this. So anyone playing at home with a pen and paper, prove the sum of 3 consecutive even integers is divisible by 6. See what the chat is saying.
Right. I did this. I actually wrote this one down.
And we'll not have. We'll make this round the last round because I've taken over 2 hours of your time, and then we'll see what they do with the exams, and then I'll put something in place that will support whatever the new. Because I don't know if you heard Joe yesterday, but our exams have been scrapped.
Great. Cool.
Yeah. And,
So, what? Isn't that, don't you need that to like graduate or?
well, we didn't have them last year, and kids were just awarded. It was a nightmare because they felt it was unfair to have everyone sit exams when everybody was in a different position due to how much time they'd spent off school.
Did different kids go? The different schools close at different times.
They have been. It's been inconsistent. The problem is because we've had our bubble system. If you've been in a bubble, let's say a year 11 bubble, and in your school a kid has tested positive, then you and everyone in your bubble goes home for 2 weeks while your friends stay in school. And that can happen. That's happened to some kids 3 or 4 times already this term. They've missed 2 months worth of school through no fault of their own.
Right.
And so even within a school, it's not fair. So we don't know what the system is. But anyway, Rumpus, I'm going to take this off the screen till you're ready to answer it.
Okay.
And you tell us when you're ready.
Right. I can share. Shall I share my screen? Show my working or?
Oh, right, if you can show your screen, yeah. So
Okay,
prove that the
I will.
sum of 3 consecutive integers, 3 consecutive even numbers, is divisible by 6.
Okay. Hopefully, where's it gone? Which window is it? There we go. That one.
So I can't
Right,
see
so
a,
that- Am I sharing properly now?
no. You might have to come out and go back in.
Yeah,
like
okay.
before.
Yeah, I did to do that. Okay, let's stop screen share screen.
Didn't you drop out the call before or refresh your page?
Yeah. Right. Does that work? Not working now? No.
No.
Okay. Let me just come back. Okay. I'll.
You can talk me through it, and I'll.
Okay. Well. Okay. You could. You end up with if you write. Well, if you think of 3 consecutive. What was it? 3 consecutive positive.
Even integers.
Right,
How
so
are you going
that's
to represent those?
right. It's right. So you do that by saying 2n, comma 2n plus 1, comma 2n plus 2. So that would be 3 consecutive, because an even number is defined as just being 2n, where n can be any number from 0 to infinity. So 2n is an even number. So you represent any even number can be represented by 2n, and so you've got 3 consecutive numbers.
With the next bit, though. You're going to kick yourself with the next bit.
Yeah.
It's not going to be 2n plus 1. What will it be? Consecutive even.
Well, it's 2 brackets n plus. Sorry, did I say 2n?
Oh,
2 brackets n plus 1, 2 brackets n plus 2. Did I not say that?
Oh, so you're doing that all in... Okay, right. I see what you've done. I see what you've done, because you've got 2 on the outside of the bracket. Yeah, fine.
Yeah.
So I've written that in a slightly different way. I've written that here.
So the way
okay.
this is most annoying not being able to.
That's okay, but I get, because basically you've just.
So you end up so you then end up with 2 open bracket n plus 1 plus n plus 2 close bracket.
Okay.
Did you,
so
yeah,
which is well,
and that's equal
type
to
one here. Go on.
Okay, and which is then equal to 2 open bracket 3n plus 3 close bracket, which is equal to 6. So then to factor out the 3, then you end up with 6 open bracket n plus 1 close bracket. So therefore, that is obviously divisible by 6, because 6 times any integer number is divisible then by 6.
I like that. I'll just talk the kids through the method I've got on here, but I like that. If we're going to represent even numbers like the Rumpus said, is going to be 2n, because no matter what n is, 2 of them is going to be even. So if n is 3, 2n is 6, it's an even number. The next consecutive even, the way I like to teach this, is going to be 2n plus 2, then 2n plus 4. 3 consecutive even numbers. If I add all those 3 together, I end up with 6n plus 6, which, so I've simplified, and then I can factorize again. And because I can factorize with 6 on the outside of the bracket, it's divisible by 6. So it's the same skills, we're just simplifying and factorizing. And Rumpus, that was spot on with what you got there. Okay. We have... I can't remember which was the next question I gave you. I'm going to give you both a question as a tiebreaker. How about that?
I think the next question was, prove that when 2 consecutive integers are squared, the difference is equal to the sum of the 2 consecutive integers or something.
Yes.
Yeah, I'm just wondering if I should give you one as a tiebreaker that you've not seen.
Ooh.
Oh.
And then whoever can prove it first is the winner. What do you think?
Oh my god, yeah, okay. I'll give that a try.
Right. Well, what I'll do, because I've taken quite a lot of your time here, and I do really appreciate it. So let me find a question for you. What were the questions I gave you on the question thing? What were the ones left?
It was the one he just said, and then the difference of 2 consecutive odd numbers squared being divisible by 8.
Yes.
Have you had prove that when 2 consecutive integers are squared, the difference is equal to the sum of the original 2?
Oh.
Yes.
Yes.
Have you?
Yeah.
Oh, darn it. Oh, I might be out of them then. I'd have to go and look at my other PowerPoint. That would probably take about 5 minutes to get them, because these aren't ones you can come up with off the top of your head. You've got to.
Yeah.
No.
Yeah, there's no risk. Yeah, don't risk coming up with an erroneous question.
Oh, no. I've got one here.
Oh.
I've got one here for you, and just let me.
Can we stay on screen so we can read it?
I'm going to put it on screen in a second.
Okay.
But this is a tricky one. It's a very tricky one to start with.
This is only on YouTube, is it? Right.
Here we go. Now, I'm going to a bit of an emphasis in this question. Prove the product of 2 odd numbers is odd. The word consecutive does not appear in that sentence. You cannot use consecutive odd numbers, or you cannot use odd numbers with a defined interval between them. So you can't have, 2n plus 1 and 2n plus 3, because there are defined intervals between them. Prove the product. So while you're thinking about that, have you got that question written down, and then I can talk to the chat until one of you shouts bingo?
of two odd numbers is odd.
Always odd. The product of two odd numbers is always odd. Have you both got that written down so I can take it off the screen?
Yeah, got it.
Have you got it, Joe?
I got it.
Okay, right. I will take that off the screen. We will interact with the chat, and then when one of them says bingo, we'll have a look. That's a difficult question, that one, because normally if you're given like consecutive even or consecutive odd, it's very, very easy. But writing an algebraic term to start off with that doesn't imply a set interval between the two numbers is not so easy. So we'll see how they do. How is everyone in the chat, and why? There we go. We're back.
Well, I've got an answer. I've got the answer.
Yep.
Oh, I see. Both your hand went up, and Rumpus spoke at exactly the same time there, which means that if you both have got this as an answer and you're both right, I'm going to call it a draw because you both did put your hand up at that right time. Okay, I'm going to just hear you out here, Joe. Can you tell me first how you did this?
So we've got 2n plus 1 and 2k plus 1. N and k are integers. You do that out.
Okay, let me get my working out up on the screen because I've got a feeling you've done this in the same way as me.
Yeah, I've done exactly the same.
Yeah.
So basically what you've done is I've used M and N. You've just used different letters because in that way it doesn't apply any set interval between the numbers.
Mm-hmm.
Yeah, I used N and P.
Right. Be any integer. And
then you've expanded.
Something, yeah, you expand it, you get something here that you can factor a 2 out of, so you know this is even plus 1 is odd.
Even plus odd is odd. Well done. Even plus 1 is odd. Rumpus, it sounded like straight away you did exactly the same thing.
Yeah, I actually had the answer before I said it, but I was just rechecking it actually. But perhaps Joe did the same thing.
So we'll call that a draw. I know in my head when I started this, and it's because I'm not very slick at live streaming, we had 5 rounds, we had chemistry to do, we had momentum to do, and I thought it would be pow, 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 and we get through it really quick, and I'm just useless when it comes to hosting streams, so we haven't got through quite as much as I'd like, but I really, really want to thank Joe and the Rumpus for spending, well, what's been 2.5 hours with me if you're counting the time since they logged onto the chat, so guys, thank you so much for that. Joe, have you got any channel or anything you want to shill out that I can put in the chat for you?
I wish. I've been doing a PhD, so I don't have time for anything. Hopefully, maybe we can do this again sometime, and I'll have something to plug then.
Well, I'm going to be doing lots of these types of streams. I'm going to refine them and get them better and slicker as time goes on because the kids are going to need it this year. So maybe one a week, something like that. So if you ever want to come back on, I'll not pester you again because you've been so good. But if you want to come back on, if you contact me on Twitter, you're on. Simply
all right. I'm in. Yeah, sure.
Yeah, it was fun. Yeah, I'll have to handle it again.
Rumpus, I think everyone knows who you are, Rumpus. But if you want to type in the chat, people can click on you. I'll give you a wrench, and people can click on your.
Thanks.
Your thing.
Yeah, I will be doing.
Your channel in.
I mean, I am hoping to do lots more videos very soon. I'm just doing some 3D work to give myself my videos a bit of extra oomph. So I'm doing some 3D modelling. So yeah, just the Rumpus. You find my channel.
Can I ask what kind of math you work on, Rumpus?
Well, I don't. I've been doing it with all this curvature, flat Earth stuff has actually led me to do quite a bit of maths, things like also a lot of perspective stuff, 3D stuff. Randomly wandering around. Oh, it's also some stuff on ray tracing and calculated variations to do modelling of the air through the atmosphere, light through the atmosphere, which was quite fascinating. I'm trying to do. I'm in the middle of writing a 250-page website on refraction, geometry. And I've had this for about 1.5 years. I haven't been doing so much of it in the last 6 months. But it's on refraction and on people have taken videos, for instance, of the Isle of Man from St. Bees. And myself and some other guy, we modelled the maths for the refraction for it. We actually used the meteorological data for the temperature gradient, and from that you can actually work out what the refraction is. And then using calculus of variations and using an iterative operation going from St. Bees to covering the 50 miles, we ended up then rendering an image which we then compared with the footage that we got, and it was exactly the same. So we were able to model it remarkably well, which I thought was absolutely tremendous. I do a lot of stuff in Mathematica, actually. And what else have I been doing recently in mathematically inclined stuff? I was answering some Lewin's question. I don't know if you know, on YouTube there's a guy called Lewin who used to lecture at MIT, who does these little problems, and just recently I was reminding myself how to solve differential equations, because there's a question he asks on how to work out the potential. Oh, that's right. Of someone, the potential at the center of the Earth, and also what would happen if someone dropped down a hole and went through the center of the Earth, and then what's the equation for the motion of that person as they fell down through the center of the Earth, assuming they went down the axis so they didn't hit the sides, and then going up. And of course, it's a sine thing. But actually, you have to solve a differential equation. I was then going to do a long video, because coming up with the wave equation is rather naughty, in the sense that you say you have something like f is equal to minus k. You have the second differential equal to minus a constant times the variable, and that obviously leads you to, that's the classic simple harmonic motion equation. And then I was going to do a little video just recently. I was just doing some to remind myself, because it's rather naughty to say the way they solve this is you put in sine x or cos x, because there you just happen to know that the second differential of cos x or sine x is the same thing plus multiplied by a factor. I was actually trying to solve it using differential equation. I've forgotten how to solve and the relationship between two independent variables. And so actually just recently I was messing around, just reminding myself. So the recent maths I've been doing actually has been reminding myself about ordinary differential equations and solving them, and second order ones. So that's the last thing I've been doing. So nothing in comparison to stuff you've been doing, no doubt, but yeah, but
well, and for those of you who've only just come or weren't here at the beginning, Joe has just recently successfully defended his PhD in physics. So I want to say congratulations before I wrap that up for you. That must have been a hell of a day.
Yes, it was.
So, yeah, congratulations. Well done. And thank you again both for being here. Thanks for being in the chat. If you know anybody that can clip out those circle theorem proofs at the beginning, give those to them. And I'll try and be a bit slicker and sharper next time. Now I've had a trial run and I know what I'm doing. But both of you, thank you so much for being here. And,
thank you for having me.
Yeah.
Oh, enjoyed it.
It was a pleasure, Cats. It was a pleasure.
I'll say bye to you off stream. I'm just going to say bye to everybody on stream now. Bye-bye.
Bye, chat.
Ended.